Okay, we're going to go through all of the skills that you need to know in Unit 8, and we're going to do the example in the right-hand column. We'll also do some extra problems at the end if we have time. So what I recommend you do is you pause the video before I do each one of these skills and you try the problem by yourself. Let the video run when you're done and see how far you get. Repeat for all the other skills. All right, so the first skill you have to know for Unit 8 is find the slope given 2 points. Okay, so you know the slope formula. And the slope formula is y2 minus y1 over x2 minus x1, which is basically rise over run, or the change in y over divided by the change in x. Okay, so for this problem here, we're going to use the points that they gave us, -1, 4, and 2, 7. Okay, and if you follow the directions in the notes, it will do exactly what I'm going to do. So the notes will tell you, let's first label these sorry. We're going to label these x1, y1, and x2, y2. That just means the first x value, the first y value, the second x value, the second y value. It doesn't matter the order, so you could have x2, y2, then x1, y1, but the numbers have to match. Okay? So the second step is to write the slope formula with just parentheses. The parentheses help us with signs, so we avoid sign errors. Okay, every time you write it like this. And then we simply fill in what we see up here, right? So y2 is number 7. y1 is 4. x2 is 2. And x1 is -1. Okay, 7 minus 4 is 3. 2 minus -1 is 2 plus 1, which is also 3. So the slope is 1. Now, sometimes we like to say 1 over 1, so that if we're going to sketch it, that's good for graphing, like rise of 1 over 1, that's good for graphing. But when someone just asks you for the slope and there's no graphing involved, we always want to reduce it and just write the smallest number, the most simplest number, 1. And that's what we're going to do here. Okay, so that was skill number 1. Let's go over skill number 2. Find the y-intercept of the line that passes through -1, 4 and 2, 7. All right, so in order to find the y-intercept, we need to find b, which is the y value of the y-intercept, and we're going to use y equals mx plus b. So we're really looking for b here, and when we find b, we're going to write the y-intercept like this. Okay, and b is going to basically go in here. Okay, all right. So really step 2 and step 3 are the same. Okay, step 2 and step 3 are the same. Step 3 includes also finding the slope. So we're going to use the same problem. So we already did this work for the slope. We don't have to redo that again. But if I was to do skill 3, if somebody's giving me this question, find the equation of a line, we'd have to start with what we did in skill 1. So we'd have to find the slope. The second step is to write the equation of the line, y equals mx plus b, and then replace every letter with a parentheses, except for b, because we need to solve for b. b is the y value. It's the number that's going to go in here. It's the y value of the y-intercept. Okay, so now we fill our numbers in. It's going to change colors to make it easier to see. So y is any one of these y's, but be careful. You have to stick with the one you pick, right? So we're going to stick with this one. We're going to use 0.2. Okay, this is 0.2. You can't use point 1 and point 2. You have to pick a point. So I'm going to pick 0.2. Usually I try to pick the easiest numbers, like positive numbers, or easy numbers like 1 or 2 or 0. I'm going to put the y value in here, see, because this is the y value, right? The y value goes in here. So that's 7 is the y value from this second point. The m goes here. Now I did the m work early in the problem. That's 1. Okay, but if it was -1, I'd put a -1 here, whatever it is. The x value from the same point that I used earlier is 2. Okay? You could have plugged in -1, 4. You're going to get the same answer. It doesn't matter which one you plugged in, but you've got to be consistent in the x and y have to come from the same point. Okay, so we plugged in the 3 things we know. The m is the slope we found earlier. The x and y from one of the points, doesn't matter which one. And then we're going to solve for b. So 7 equals 1 times 2 plus b. And finally subtract 2 from both sides, so b equals 5. Okay, so we answered question 2, skill 2, but skill 3, right? Skill 3 is the same thing. It's just to do both at the same time. So it says find the equation. See, find the equation. As soon as I see that word equation of a line, then I know they're talking about y equals mx plus b. So we're actually done with that because we found the m and we found the b. So you fill in the m and the b. You need the leave the x and the y alone. So it's mx plus b, and b was 5, right? By the way, I forgot to fill this in over here for us for the y-intercept, but now I did. I'm going to abbreviate intercept int, but of course you can write it out. And then it's going to be plus 5, okay? That's the y value of the y-intercept goes here. Now, this is actually not the right answer. It is correct. You could graph this and it would work, but we never include 1s in front of x's as standard form. So all we're going to do is change this by dropping the 1, but it's still there. It's still there. So even when you see a line like this, or -x, for example, right? There still is a slope even though there's no physical number there. And if there's no physical number there in front of the x, then it must be 1. So when you see y equals x plus 5, you know there's a slope of 1. It's hidden here. We're not going to write it, right? We're going to undo it because we're not allowed to write it in the final answer. But there's a slope of 1, and the y-intercept is 0, comma, this number, right? Right up here. You can see it right here. 0, comma, this number. Okay? And then finally, the fourth one is find the x-intercept of a line. All right, so if we look at a graph, we know that x-intercepts happen when it hits the x-axis, right? So here or here, this is a lot of different things. The common thing about these black dots on the x-axis is, right, here's the y-axis, right? Here's the y-axis. So the common thing here with the x-axis is that all of these points have a y value of 0, right? So this could be 2, 0. This one here might be 3, 0. This might be 6, 0. Excuse me, this might be -1, 0. They all have y's or 0. So all we do is plug in 0 for y. That's how you find the x-intercept, because the x-intercept is a point on this line, but it's a point that has a 0 for the y value, see? Going to look like this. And of course, I don't know what this is yet, okay? So we call this the x-intercept. And again, I'm going to abbreviate intercept as int period, okay? But it's the x-intercept. Y-intercepts have 0 for x. X-intercepts have 0 for y. So I plug in 0 for y, and I solve for x. Okay, so I'm going to subtract 5 from both sides. I'm not going to show that work because we're out of room here. X equals -5, and I plug that into my ordered pair here, right? That's an ordered pair, meaning that's an x and y coordinate with parentheses and a comma, and that's my x-intercept. So when anybody asks you for the y-intercept or the x-intercept, it's always an ordered pair. Okay, we're going to go to skill 5, which is graph a line given the equation. Okay, so now we have, this is a different, okay. So for number 4, I didn't actually do this problem. What I did is I found the x-intercept for the problem that we found in steps 1 through 3. So I didn't do this problem here. You could try that on your own. Okay. So pause the video. I'm going to pause the video right now, and try to find the x-intercept, this skill number 4, and then I'm going to go over that. Okay. So try to find the x-intercept for number 4 now that I just showed you how to do it. Okay. So to find the x-intercept for number 4, we're going to plug in 0 for y. Right, so if I go back here, it's y equals 2x minus 6. Now it's 0 equals 2x minus 6. Why? Because whenever somebody asks me for the x-intercept, I always know the y value is 0. And the x value is to be determined. Okay, so I solve for x. So I'm going to add 6 to both sides. And then I'm going to divide both sides by 2. I'm not going to show that work. You know how to do that. It's pretty easy. So x equals 3. So that's the x-intercept you should have gotten when you paused the video and tried this problem for yourself. Okay, all right. Let's go to skill number 6. So 5 was graph. Oh, sorry, 5. Graph a line given the equation. So we're going to do number 5. We're going to graph a line given the equation. So y equals 2x minus 6. Y equals 2x minus 6. Okay. And I'm going to call up some graph paper here. So let's write it. Y equals 2x plus 6. Okay. So to graph the line, I'm going to look at the b, which is 6, and that tells me the y value of the y-intercept. Okay. The y value of the y-intercept. So it's 6. So it's actually off the screen here. So what we're going to do, right, is I'm going to ignore this. So I'm going to pretend this is not my x-axis. Otherwise, it's going to be too hard to do. Okay? So I'm going to ignore this. And I'm going to put my x-axis here. Otherwise, we're going to run out of room. And I'm going to call this x, and this is y. So we're just going to ignore this line that I crossed off here. Okay? And of course, this is 1. You should be able to label an axis like this. This is 1, 2, 4, 6, right? 8. Okay. So y equals 2x plus 6. So we look at the 6 and we go, oh, that's the y value of the y-intercept. So the y-intercept is the ordered pair 0, 6. Where is 0, 6? Well, here's 0, 0. So we're going to go up to 0, 6. There it is. We make a nice big dot. So that's 1 point on my circle. We then look at the slope of 2. And if it's an integer like this, we're going to convert it to a fraction, right? You can make any integer a fraction by putting it over 1. Because we want to think of rise over run. I talked about this earlier in the video. So I want to think about this as rise over run. So rise is how far you go up from your initial point. And 1 is how far you go across from your initial point. Okay? So we're going to do a rise of 2 and a run of 1. So rise 2 is up 2 over 1. Now again, if we keep going, we'll go off the graph, and I don't want to do that, right? So the other thing you can do is, if you think about 2 over 1, it's also equal to negative 2 over negative 1, right? Negative 2 over negative 1 is positive 2. 2 over 1 is positive 2. So I actually can go down to left 1. So my rise would be negative 2. So let's do that. So from 6, I'm going to go down 2. That's a rise of negative 2. And then a run of negative 1, which would be here. And if I did it correctly, all 3 dots should be in a straight line. And I can keep going like this, down to left 1, down to left 1. And I can use a straight line tool finally to connect this. I didn't put arrows at the end. I will add them manually. You always want to put arrows for a line because lines go on forever unless somebody specifies differently. And there we go. We did skill number 5, which was graph a line given the equation. It's not a great example because, oh, it's -6. Oops. So just a quick correction, guys, here. I could not read that because I had to make it really small. So I've been doing the work of y equals 2x plus 6, which is probably why you may have gotten a different answer from me. Okay? So apologies about that. The only difference with -6 is we would have started way down here and done the same thing. Okay? So I did graph a slightly different problem here, but it does work the same way. The only difference is -6 would be way down here, and then you'd go up 2 over 1, up 2 over 1, up 2 over 1. Okay? So again, for the last few minutes, I've been using y equals 2x plus 6. If you just change that here and then try it yourself, that's fine. Okay, 6, recognize the slope in all different forms. All right? So find the slope for these two. So in this first one here, x over 2, all right? I'm going to make a new slide, so x over 2. So if you see y equals x over 2 plus, I don't know what it was. Let's see, plus minus, okay, -1. Doesn't really matter for this purpose. Okay. There's always a 1 in front of x that we never see. So if you see a blank in front of x, right, there's always a 1. So this is actually the same thing as 1/2 x. It's just a neater way to write 1/2 x. X over 2 and 1/2 x are the same thing. So the answer to this problem is the slope is 1/2. Okay, so that's for this one here. Now for the next one, y equals x, right? Same kind of thing, y equals x. Y equals x. What happens? Oh, there's no number in front of x. Well, that means it's a 1, okay? Always. And there's no b, right? There's no b, so that means the y-intercept is 0, 0, because b is 0, so it's really plus 0. But this one, they're only asking for the slope, and so the slope is 1. Okay. Let's see what's next. Oh, the last one, y equals 6, okay? So sometimes you don't see any slope, right? Y equals 6. Now I'm going to write it a little funny here. Y equals 6 is actually y equals 0x plus 6, but we don't write the 0, okay? So we got to remember, I did this in class, or if you're from a different teacher, I'm sure your teacher did this many times. Horizontal lines are always y equals a number, right? And vertical lines, which a lot of you tend to call straight lines, but all lines are straight, right? Straight line doesn't say anything to me. Or sometimes you call diagonal lines straight lines. Horizontal lines and vertical lines. Vertical lines are x equals a number, okay? So when we saw y equals 6 like this, we know it's a horizontal line because the slope is 0, okay? Y equals 6. Now, x equals is a different line. That's not this line. That's a totally different problem. So if somebody says, what is the slope for x equals minus 3, right? Well, that, if I was to graph that, x equals minus 3 looks like this. It's a vertical line, okay, passing through, all of the x values that have negative 3, which is all of these points, right? This dot has negative 3 for x, this dot, all of them. So that's a vertical line, so that would be an undefined slope, okay? Undefined. Sometimes we say no slope, but that gets confusing with 0, so we like to stick to undefined slope. Okay, so those are the 3 slopes we got out of these 3 problems, okay? Put an equation into the form y equals mx plus b, all right? So this is really kind of a C problem, but 4x minus 2y equals negative 12. So 4x minus 2y equals negative 12, okay? So what happens here is we need it to look like y equals mx plus b. So I have to basically get y alone, so I'm going to isolate y. So I'm going to subtract 4x from both sides. Notice I'm going to put it in the front though, right? So instead of negative 12 minus 4x, I'm going to put the 4x in the front. And that's because I see this form, the b, which is the number by itself, the 12, well, whatever it's going to be, it's not 12, is over here, and the x term is over here. So the last thing I have to do, which is kind of difficult here, is y is being multiplied by negative 2, so I need to divide both sides by negative 2, and that means every term by negative 2. So finally, I get y, which is what I was trying to get, and I get negative 4 divided by negative 2 is 2x, and then plus 6. Okay, and that's now in the proper form. Okay, that was number 7. Number 8, find the slope and y-intercept of a horizontal and vertical line. So I kind of just covered that. The only different thing about that, right, would be, I'll just draw a rough sketch here. Y equals 3, for example, would be 1, 2, 3. So y equals 3 would be this line, okay? And so when someone says, what's the y-intercept? Well, it's actually easy because y is 3. We already know what x is. Y-intercepts always have the same, right? Okay? That's the y-intercept, the y-intercept. Now the x-intercept is where does this purple graph hit this x-axis down here? The answer is it doesn't. So it's no solution, right? Or undefined. Now for a vertical line, okay, let's take the line x equals 1, which would look like this. Let's take the line x equals 1. I'm a little off there, but you get the idea. It should be hitting here. So when someone says, what's the y-intercept of that line, right? The answer is undefined. Okay, only x equals 0 would have a y-intercept, and it would be all of the points. But we usually don't ask you that on the CP level here, okay? So you don't have to worry about that. But the y-intercept is undefined because it doesn't hit the y-axis, but the x-intercept is, of course, right, some number comma 0. And of course, that's just the x value that they gave you, so it's 1 comma 0. All right, the next skill is graph horizontal and vertical lines. I just covered that, so I'm really not going to do that again. In fact, I think I did these similar examples to these. So I'm not going to cover that. There are vertical or horizontal lines. They have to pass through those x values or the y values for horizontal. So I think that's kind of obvious. 10, write the equation of a line given a slope and a y-intercept. We've already done this too. Okay, so we're going to do it anyway. M equals negative 2/3, and the y-intercept is 0, 2. So if you want to pause the video and try this yourself, and then when you're done, unpause the video. Okay, so M equals negative 2/3, and the y-intercept is 0, 2. So the y-intercept is 0, 2. Okay, so basically y equals mx plus b is the form we're going to use for now anyway. And I need to fill in the m. The y and the x stay the same. So I need to fill in the m. The m is negative 2/3, so you can kind of write it like this. And then plus b. B is the y value of the y-intercept, so it's plus 2. And that's a good enough answer. We do sometimes make this a little more compact, so you may see this like this. It's a little more common. Okay, all we did is we multiplied x over 1, right, by negative 2/3. So numerator times numerator, denominator times denominator. This just stays the same. So that's a little more common way of writing it, but both would be acceptable on a quiz. You don't have to worry about either form if you're writing it yourself. Okay, let's do graph any function by creating a table of values, selecting x values, and finding points. All right, really this is from last unit here. So negative x squared minus 2x and plus 4. Okay, and we're going to make a table of values. We usually like to pick the same 5, right? Negative 2, sorry about that, negative 1, 0, 1, 2. Okay, and then we plug them in, right? So we're going to find f of 1, for example. Well, actually, we'll start in order. So we'll do f of negative 2. So we'll do f of negative 2. Okay, and then what we do is we replace every letter, you've done this a million times in class, with a parentheses, okay? And then we take turns plugging different numbers in. So we're going to do negative 2 here, right? Negative 2. Why am I doing that? Because it's the number I picked. Okay, so this equals negative 2 is 2, I'm sorry, I forgot the squared. Very important, right? Let's start again. Very important. I forgot to copy down this 2 here. Okay, so it's minus x squared minus 2 parentheses 2x and then plus 4. Okay, so starting at negative 2 times negative 2 is positive 4 times negative 1 is negative 4. Minus 2 times minus 2 is positive 4 and then plus 4. So you can see that that's going to be equal to 4. And so I get my first point, negative 2, 4. Okay, now I can repeat it. I can actually even leave my work, or I should say erase my work and do this for each one if you want to. It's not terrible to do this. Okay, now we're going to do negative 1. Don't forget the squared, by the way. Okay, so f of negative 1 equals negative 1 squared, which is 1, times minus 1, which is minus 1. Negative 2 times negative 1 is plus 2, and plus 4. So I think you can see that that's going to be 5. Okay, and then you keep going like this, and eventually the shape will take form when you plot all your points, right? So negative 2, 4 is going to be up here. Negative 1, 5 is going to be here. Okay, 0 is a real easy one. So 0 is 4, because if you plug 0 in, both of these first two terms go away. So 0, 4. Okay, and if you keep going, I'm not going to do all the points. You understand how to do the rest. It's going to make like an upside down parabola like this. Okay, and I'm not connecting it through the x-axis. Well, I'm not labeling where it's going through here. By the way, that's a pretty terrible parabola. So parabola should look more like this. Parabola should look more like this. Okay, they never point straight down. They're always still going down and to the left, but it's not like a V like this. It's more curvy like this. but on my digitizer at home, it's actually kind of difficult to do. Okay, that's a graphing function. Use an equation of a line to predict an x or y value. Okay, so I'm going to go back to all right. We'll do two birds and one stone here. So we'll actually do what's a skill that's called converting a word problem into an actual equation. So the temperature is dropping 3 degrees per hour. When you hear per hour, that's a rate, which is a slope. So it's dropping 3 degrees per hour. So now I know my slope is -3/1 if I'm doing graphing, right? Because it's down 3/1. So it's -3. So it's -3 degrees per 1 hour, right? So over 1 hour. But for the equation part, I'm just going to leave it as -3, right? I want to simplify it. Okay. So it says the temperature is dropping 3 degrees per hour. That's a rate. That's a slope. It started off, so starting point is the y-intercept at 15 degrees. Well, I should say that's the y value of the y-intercept. So 0, 15 is our starting point. So our y-intercept is 0, 15. Okay. And so then the letter B, which is the y value of the y-intercept, is 15. That makes it pretty easy. Okay. Write the equation for this line and figure out when it will be -10 degrees. Okay. So write the equation for the line, which is so easy now. We just put the m in, x, and plus b. By the way, sometimes we would use different letters. Like this looks like it's temperature and time, right? So time is usually T. So sometimes somebody may write C equals -3T plus 15 because T is a better variable for time than X is, but it doesn't matter. They didn't specify, so it doesn't matter. You can use either one of these. You can make really any function name you want. I would stick with X or T though, and T for time is always a good one. But I'm going to go back to what you probably did on your own, which is this original one. So figure out when it's going to be -10 degrees. Okay, well, this, right, is the degrees, right? This is time, right? Time. And this is the degrees, right? Probably Celsius. I didn't really look that carefully at the problem. So when they want to know what is it going to be, I'm sorry, when is it going to be, right? So when means what is the t value or x value if we're going to use our equation when it's -10 degrees. So when y is -10 degrees. So we're going to put -10 degrees in for y. And we're going to find the time, which is x here. If we're using this one, it'd be t, doesn't matter. And there we go. So I'm going to subtract 15 from both sides. So that's -25 equals -3x. And then I'm going to divide both sides by -3. And I'm going to get a weird number. I don't think it was supposed to be that weird, but it's going to be +8, right? So it's going to be 8 1/3, right? Because 8 times 3 is 24. That's a remainder of 1. So 8 1/3. So about 8 hours and maybe 22 minutes, right? A third of an hour. I'm sorry, 20 minutes. A third of an hour is 20 minutes, excuse me. So it would be 8 hours and 20 minutes because 1/3 of an hour is 20 minutes, right? 60 minutes in an hour divided by 3 is 20. Okay, so that's what x would equal, 8 1/3, and that's what they're asking for. Okay. Determine if a point lies on a particular line or not. So in other words, y equals 2x minus 3, that same one that we had before, even though I did change it, if you remember. Okay, so it says, is this point to -4 on that line? Well, if it was, you should be able to plug it in and get a truth. Okay, so in other words, I should be able to plug the x value in and plug the y value in, and it should be true. And let's see if that happens. So 4 equals 2 times -2 minus 3. So 4 equals, and if you wanted to, you could kind of put a question mark here, like, is this true? -4 minus 3, and then of course you see what? 4 equals 7, so it's not true. That point is not on this line. Okay, even though a line has an infinite number of points, it doesn't have all the points in space. So this line did not work when we put it in the equation. And then finally, remember to be ready to use all your skills from previous units, including range, domain, interval notation, function notation. I was using function notation earlier, for example, so that's a good one to, of course, practice as well. Okay, guys, I hope this was helpful for Quiz B. I know that I went over Quiz A with my class. I'm sure your teachers will go over Quiz A also, or did that today, probably, if you're watching this on the weekend. But hopefully this gives you a big overview with a sample problem of each type of skill you need to know for Quiz B and also for Quiz C. And just remember that I did slightly change, right, that problem from skill 4, y equals 2x minus 6 was the original, but I used y equals 2x plus 6. I copied it wrong. But the process is the same, and you feel free to try it. Remember, you can always test things in Desmos, right? So if somebody said to graph something or find the y-intercept of a line, you can go into Desmos, type in y equals 2x minus 6 or whatever the equation is, and then you can see the x-intercept and the y-intercept clearly on the screen. Okay, guys, good luck on Quiz B.